Lesson 1 of Engineering Mathematics. Real numbers. What are real numbers? Real numbers are numbers that are found on the number line. It can either be on the positive or negative axis. Real numbers can be classified as either rational or irrational numbers. What are rational numbers, per se? All natural numbers, integers, fractions, and equivalent decimal values are classified as rational numbers. It is mostly commonly written as m over n, and n does not equal to 0. For example, we have 420 is our given value. Its common form would be 420 over 1, because 420 over 1 is simply 420. And note that n, which is the denominator in this, does not equal to 0. Another example would be negative 911, and it will have a common form of negative 911 over 1. Next would be fractions. Fractions are part of a whole. It is a ratio of the part of a whole. There is a line separating the integers called vinculum, or usually called fraction line or fraction bar, wherein the number above this line is called the numerator. This is the numerator in this example. And the number below the fraction line or fraction bar is called the denominator. For example, if you have a pizza and it's been cut into 5 slices, a person eats 2 slices, so you will have 3/5 of the pizza left. Since as a whole there were 5 slices, and 5 slices take away 2 would be 3. So there are 3/5 of the pizza left. Next would be decimals. Decimals are basically the numerical value of a fraction. It can be classified as terminating or repeating decimals. Repeating and terminating decimals are rational, and non-repeating and terminating are irrational. Example of a repeating decimal is 0.123123. This is repeating because there is a number sequence, as seen in this example. An example of a terminating decimal is 0.123456. Why is this terminating? Because it has an end. And this is not a repeating decimal because there is no number sequence. It does not repeat the same numbers over and over, unlike the first example. Integers. Any number found on the number line is an integer. But note that fractions and decimals are not classified as integers because integers are whole and natural numbers. We have 1, 2, 3, 4, 5. These are integers. And -5, -4, -3, -2, and -1. These are also integers, since all these numbers are found on the number line, whether it's on the negative or the positive part of the number line. Whole numbers can be found between 0 and infinity, and natural numbers comes after the 0 mark with an ellipsis indicating that the numbers continue to infinity. Like in this example, we have a sequence of 1, 2, 3, 4, 5, followed by an ellipsis, indicating that these numbers go on until infinity. Next, we have irrational numbers. These are numbers that cannot easily be expressed. They may not even have a definite value, and it's neither repeating or terminating decimals. And A prime example of an irrational number is pi. But why? Why is pi irrational? First, pi is the ratio of the circumference to the denominator, and its value is neither repeating nor terminating. Therefore, it can be concluded that the value of pi is irrational based off the definition of irrational numbers. And to give an example, we have to evaluate the expression and identify its type of real number. In this example, we will use the PEMDAS, which is abbreviation for parentheses exponent, multiplication, division, addition, subtraction. Here, we have to solve the value inside the parentheses first. So it will go here. 10 times 6 is 60. And then we copy minus 2 times 3 plus 16 is 19. And we square that because there's a parenthesis in square. And then we solve with the exponent. We distribute the squared to the 19, which is inside the parentheses. And 19 times 19 will turn out to be 362. Next would be multiplication. We distribute negative 2 to 362, and we will have negative 722. We just copy the 60. After that, we subtract 60 to 722. It will turn to be negative 662, and negative 662 is a rational negative integer.